Olá, Facu de la Cruz. Obrigado por estar com a gente no Cyber Security Summit e é com você.
Hello, everyone. My name is Facundo de la Cruz. I work as cyber reliability engineer for an American company based on artificial intelligence, machine learning. And today I will be talking about the way that we used to build the next generation infrastructure in the cloud and how it can affect the security of the different applications. Okay, let's start. Today we will be talking about GitOps. But what is GitOps? GitOps is probably the next highlight in the technology industry, and it's only a philosophy. It's not anything else. It's only a philosophy in the way that developers create, build, and deploy their applications, right? We are passing from an approach where we say something like, we want to create a Redis server, we want to create an application server or a database server, to we have this application server, we have this database servers, we have this Redis server, right? And with GitOps, something that we are doing is becoming the VCS, the virtual control system, in the central part of the infrastructure. So what is that? Basically, what we are doing is declaring in our virtual control system all the applications that we want to have running in the cloud. It could be a public cloud or it could be a private cloud too. So you decide where you want to build that. But what's the point about that? It's about the automation. It's about the way that people need to deploy their applications, and also the way that they have to automate that, reducing the effort of the operations team, right? But how it's get close to security in some point? It is basically because you can automate a lot of different things and you can audit the code that you are deploying. Well, you can run automated scans in the code that you are deploying, and you are going to deploy everything in, for example, Kubernetes or any other image orchestrator, right? Right now, almost all the internet infrastructure is based on Kubernetes. So for that, for base all the infrastructure in Kubernetes, we have different approach, and GitOps is a new one. Well, since we started talking about the VCS, that is becoming the central part of the infrastructure, we need to think in the way that we can design this automation, right? We are using Kubernetes that is designed for automation from the beginning. And once we have this tool, we can create different pipelines, different flows to deploy all the applications in the Kubernetes cluster on all the Kubernetes cluster that the companies or the organism has. Well, but there is a point here that teams need to know a little bit about that before start deploying change. Deploying changes basically means that teams is aware about what they are doing, how they are applying this change in the cloud, and basically in all the different tools that they are using to deploy. There is actually a need for traceability in the different components, and we have that with this approach. Basically, what we are doing is having a VCS that it could be GitHub, it could be GitLab or Bitbucket or whatever. It could be the public one or the private one. And basically, in the VCS, you have the history where all the changes are made, right? You have something linear about the history or not. And imagine that you want to create another database server. So what you are doing here is just create another branch, start committing to this branch, right? Once the changes are done, somebody creates a pull request if we are using GitHub, or a merge request if we are using GitLab. And then it's open the discussion. It creates a pull request page where people start discussing about the different things about the change, about the way that they are implementing something. So we have the traceability here in the same history in the repo, right? So after that, we can start saying that the repository becomes in the single source of truth. Everything that is in the repo actually is the truth about the application or the component that you want to deploy. And since a few years ago, YAML is becoming an industry standard for infrastructure, also for the applications. So we are switching from pull-based deployment, where an orchestrator or any other tool is pulling the change from the repository, to push-based deployment. It means that when somebody sends a push to the repo, it will bring all the change in the infrastructure. And also you can run hooks that make the integration much better. Well, but as we said before, we have a branch master that is the single source of truth of everything. It's one of the different approach about the Git flows. In this case, it's the Github Flow, where everything in the master is a single source of truth. And keep in mind this situation. A team needs to implement a new change, a change in the infrastructure or a change in the application. So the developer creates a new branch. They start committing here. For example, they send 3 commits, they analyze them, they discuss about that. And finally, the commit is merged into the branch master. And with that, all the changes in master becomes deployed in the infrastructure. But before, you can run some tests, for example, here, if you want. People will discuss, will run tests, and then will merge eventually, if the change is okay, to the master branch. So we have 4 different facts about this approach, this GitOps approach that we are trying to implement. First, the entire system is described declaratively. Basically, what we say is we declare all the different components using YAML. That is the standard in the industry. And we have 2 different states here. First, we have the canonical state and the desired state. Basically, the canonical state is what we have running in the infrastructure, and the desired state is what we want to have running in the infrastructure, right? We have 2 different states. Canonical is what is, for example, what the infrastructure has before reconciliation, and the desired is what we have right now, right? We want to have. Basically, both states are versioned in Git, or in this case is GitHub, but it could be also GitLab or any other VCS. And only the approved change that cannot be automatically applied will go to production or any other environment that we want to deploy, right? But how we reach this point in this point in automatization? Basically, we use software agent to ensure correctness, and we will alert when we have divergence on the status, right? In this case, we will be using a tool called Argo CD. That is a tool that will integrate what we have declared in the repositories and what will we deploy in the cloud. Well, let's start talking a little bit about the first fact. Basically, we are using YAML to declare all our infrastructure. Yes, YAML means yet another medical language, and basically is a language created for humans. The main difference with JSON is that YAML is for humans, JSON is for analytic usage, you know, for understanding in the different software components, right? If you try to contact the Kubernetes API, you will need to send, in this case, if you are using the API, you will need to say JSON, right? And basically, with this standard, you can have some templating, in this case, Helm or Helm file or customize. What Helm does is basically render a template in YAML. Basically, when you're creating an object in Kubernetes, something that you are doing is creating a YAML file for that. And after that, you will need to make some change because one environment is different to the other environment. So for that, you enable some templating in the YAML, and it's what Helm does. For example, if you have a dev environment, you will need some changes. And if you have a prod environment, you will need, I don't know, any other change. Or also you can customize a little bit the template, and you are doing that by using Helm, right? So once we have that, we have the YAML, and we have templated the YAML first, we have something that is easy to reproduce. We can implement that everywhere, in every cloud, right? So doing that, basically you can create a new environment in just a few seconds. Well, the second fact is that the canonical and desired state are versioned in Git. Well, basically, as we said first, we have the status that we want to have and the status that we have, actually. So basically, both status are versioned in Git because you have a history in your repo, and every time that you commit something, you will find in the blog the change that you have for the repo, right? Will be a few deltas in time where what we have deployed differs a little bit with what we have declared in the repos. So the action will ensure that it will be the same. And this is the point about GitOps. So every time that I send a pull request and somebody approves the pull request and it's merged, it will take the change from the repo and will implement the different changes in the infrastructure, right? So for that, we will need to keep a clean history in Git. Otherwise, it will be a mess to deploy. So it goes a little bit depth on the infrastructure point of view because we need to have teams who work well with that, use a Git strategy to implement the change. So the main point here, the main fact is about the Git flow. We need to have a very consistent Git flow across all the teams in the organization, right? So with that, we can think in another scenario. For example, keep in mind that you have your changes in Git and you need to revert to a specific change. For example, in the case of a system failure, you will have the history and you can make a Git revert and go to the point in time where you want to recover. So it's a very good point in the case that you have some kind of system failure. Well, approved change automatically will be applied. And the point here is that we will be creating a pull request or a merge request, right? And once we have the pull request, not only the developer will be seeing that, the entire team will be checking the pull request that is going to be applied. So you will have more people involved in a single change. So for that, it's interesting the point that only the changes that are applied will be going to the different environments, going to the pipeline basically. And in the meanwhile, you can run a few tests if you want to run, right? So in the case that something fails, you can create a Git revert and you will be coming back to the point before the failure. So rollback is really easy to do. And finally, we have a few software actions to ensure correctness. And in this case is the tool that we will be working. That this tool has an operator that basically will be checking for the different changes in the repo, right? If somebody submit a pull request and the pull request is approved and merged, it will check the code for changes and will be bringing all the changes into the infrastructure. So you don't need to be using any other tool to deploy application. You only will be using this tool to bring all the change from the repo and finally create them. We will be seeing that in a demo in a few seconds. So the benefits about GitOps are basically it promotes faster development because once the change is approved and merged, it will be going to the different environments. Also, you can have better operations in your company because it reduces the time that is needed to deploy changes. It helps in security because you can run automatic scans in the code that you're deploying. Obviously, the compliance and auditing will be easy because you have everything declared as a code, and the experience for developers is improved. Well, finally, we have another key component here that they are the Kubernetes operators. Operators basically are software extensions that extend the Kubernetes API, right? If you want to create something that is not declared on the Kubernetes API or you want to create a new kind of object, so you will need to use an operator for that. You can create your own operators. In this case, we will be using the Argo CD operator that creates, for example, the application kind in Kubernetes. So let's go to the demos just for 1 second. Well, I will close here for a moment, and I will go to this application that we have here. For example, I have created this endpoint, flask app tti0.guru. So I will open that, and we have this small application. It's a very, very basic Flask app that I have created here. So I am using Argo CD to deploy this application, right? We have this application here. I can see the view for the app, right? We have the pods, the deployment, the replica set, right? And also the ingress rule on all the different components that the application involves. We can switch between different views, right? It's about the pods, for example, and the node statistics, and also about the network point of view of the application. And we can see that it's synced with what we have in the repo, right? We are pointing to the repository head. In this case, the latest change out to the repo, and we can see the sync status is okay. So if I go to the repo here, I can see that is the application that I have created before. Basically, something that I'm doing, I have this small pipeline where first of all, I start linting the code. I like linting because it avoids any kind of errors about, I don't know, people committing a public key, for example, or AWS credentials or whatever that does not match the test that you define in the action. Then we started scanning the image that we are creating, and finally we build the image and push to the Docker registry. So if I go to the actions here, I can trigger anytime that we want. For example, I have this one trigger. I will run all shops, and we will see that it first will start linting the code, then it will go to the security scan, and finally Docker build and push. Well, you can inspect the action itself. It normally takes a couple of minutes to run, but something interesting about this second stage, security scan, is that it's scanning all the code for vulnerabilities. So if I go here to security, I can see all these alerts that we have in this application, right? You can inspect every one of them, and also it ensures you that you will have clean code running. You won't be bringing new code with vulnerabilities or any other kind of errors. So your code is clean, and it's good to go to the cloud without any other issue. So it's interesting about that because you are having in advance some security advisory about the application that you are going to execute. So it's taking all the advisor from an external database, so it's continually update, and it's a good thing to know that your code will run cleanly. So if I go back to the actions, I have this one, for example, Python lint worked well. In this case, it was green, the status. Actually, it's running the security scan, and finally, it will build the new Docker image. So, but what's the point here? The point here is that if you want to update that, in this case, you will create a pull request for the application. But also something that you can do is create different objects to try to deploy that. And it's something that we will be doing right now. Basically, this application has a small message that we have here. We will try to update that. So for that, something that we'll be doing is I will go to the repo in my console. And here in the repo, we have the demo Flask app. And this application has a chart that is defined here in the header. So I will go to the chart. Let's enter to the directory, and I will be editing the values.yaml. And in this case, I will change the salute variable, and I will change the header too. So basically, I will be using this image and this other message. Well, I am just checking for the correct name of the variables. and I will be deploying that. So for that, I will create first a new branch. Right, my branch has been created. I will add my changes. I will commit my change. Update header will be my message. Now it's run a few tests that I have installed with pre-commit hooks, just to be sure that I am not committing any credential or also some style checking. And I will sign my commit with my CPC key. Well, I have it done. So now the only remaining thing is pushing the change. I am pushing here. I will create the new pull request with this URL. Let's create empty, just that. We will see here the change that we did. That was basically update header here, right? And finally, let's go back. We can see a few actions running. It will be running a few tests that we created automatically in the workflow. But I will merge the pull request right now. Well, let's delete the source range just to keep things clear. And now, if we go back to our application that we have defined in Argo, we will try to sync it again because we changed what we have in the repo. Actually, the message is completely different to the original that we have before. So I will be executing that. It takes 3 minutes to run automatically, but I am syncing here just because to save some time, I am forcing the sync. But you can see now the pods are being replaced. If I go back to my Kubernetes cluster, kubectl get pods all namespace, we will be seeing all the pods being created again. Right, it's terminating the old ones and the new ones are just in place. So if we go back to our application, we'll be seeing its updates. Well, it worked. So what we did here, something that we did here was create a SSL certificate by using Cert Manager. It's part of the Let's Encrypt project. And also we create the DNS registry for that. But you didn't see that, so let's create it again. So we have actually our application sync, but also something we can do is edit the parameters for the application. Let's go back here. I will try to refresh my screen. Okay. Let's send the port forward again. Okay, we have our application here. Sorry, a small network issue. We have the application details, and we can edit the parameters here. Basically, I can change, for example, the message. In this case, let's write something like this. Let's save the changes. And now our repository was out of sync and new pods are coming. You can see them being deployed here, right? All the options will be created. And if you check again the kubectl output, you will see the new pods coming. HEPI is an alias that I have for get pods, right? New ones are coming to the system. We are deploying again. So if we go back to the browser, we can see the new message here. Well, it was basically what Gitops does. You can see the desired state and the canonical state, and basically we are syncing them. In the first case, I just open a new pull request, merge that, and new change automatically went to the servers in the cloud, in this case, a Kubernetes cluster. So I add an application here. You can see the application running, everything good so far, but probably you want to add more applications. So how can you add more applications? So basically, we have this small application that we'll be closing here. Basically, I created a Helm file is an abstraction layer over Helm. Basically, what I can do is just override the values and define them by environment, for example, or any other function that you want to use. We have this small Helm file here where we are defining all our applications that we have. First, let's go to the chart. In the chart, you can see that there is the application.yaml file, and we are defining here all the applications by using the CRD. And the CRD of Argo creates the type application. So something that I can do is get applications, and we will see, for example, in this case, just one defined here, the demo flash app, that is the application that we were working before. So we can see the sync status and the health status of the application. So let's create another one. We can dump it as a YAML file, for example, and you can have all the definition about the application. But in this case, let's create a new one. So for this repo, here I have a pull request open. This pull request has been approved. We have a reviewer here who checked the code first. This person was checking first the code, and then after that, we are ready to deploy the changes. So for that, something that we will be doing is just as another reviewer, check what we changed. And in this case, we will be adding this other application here, demo hello world app. So for that, I am going to approve the change and merge the pull request. The pull request has been merged. Now, if we go back to our Kubernetes console, we will see not yet, but we can sync the applications here. Oh, sorry. It did not apply yet, so let's check the actions. Well, let's go back here to the actions. Okay, it's still applying. Normally, it can take a few times to run the shop. It depends on the cloud, in this case, the GitHub cloud. And let's check for the still working. Let's refresh my screen. Normally, it takes a little bit of time. Well, it's setting the Helm file. Now it's create the template. It's logging to AKS. You can configure that in your GitHub repository. It creates the template. It started the syncing process. And it's done. If we go back here, we will see the new application starting to work. So in this case, now we can see the demo hello world application. And something that it does is automatically creates the certificates and the DNS register for the new app, right? So if I am hosting my DNS in Cloudflare. So if we go to the Cloudflare console, let's log in. We will see the new app in the DNS. So we forget about creating new DNS register. It will be done automatically by our pipeline. In this case, we have it here. It's pointing to load balancer in Amazon Cloud Computing. And also, it will take a few seconds to create the certificate. I can use kubectl get certificates to see that the new certificate is ready and has been signed by Let's Encrypt, in this case, Ser Manager. And also, you can check the orders. Well, in this case, we have this one. The other one is still in progress. So now if we go to the DNS that we have created, hello world.tty0.com .guru, we'll be seeing the new application. Let's open it here. It can take a few seconds the first time, and we have everything in place, and also with the certificate enabled. Well, we can see the CA that is signing the certificate, and in this case, it's lesson create, but it supports any other CA that is integrated with Cert Manager. Right, we created a new deployment by just adding a line in the repo with the pull request that we merged before. So basically, here in our repo, we can create different application, but adding one line in the different repository that is working as an agent of sync between the cloud and also between the repository. So with this approach, the only thing that you do is just declare what you want to have, and it will be going to the cloud. Here we run a few actions, and also we run a few security scans if we wish to have that, and we can audit the code in the point that you can detect in time in advance any other, I don't know, any vulnerability that you have. So, well, finally, to close this presentation, we will be talking a little bit about chaos testing. And for chaos testing, I decided to make something different and try to make it funny. Chaos testing is an approach that comes from Netflix that means breaking your infrastructure and checking if it's recovered. So for that, I decided to make it in a very nice style. So let's forward my ports and let's go back to the browser. Just 1 second. Okay. And now if I go to the localhost 8080, I can destroy my infrastructure in the Wild West style. So we have a service here that appear, a pod. And if I go back to my console, I will be going back. Let's destroy a couple of them. And we are scoring. We will see the pods being repaired. Probably it depends on the time in the response, right? But we can find them by the time here. Let's destroy a couple more of them. And you can see here the pod name that you want to destroy. So you can check that the infrastructure is resilient. If the application still works, it means that your infrastructure is resilient to the changes and also to the chaos testing. So it was everything from my side. Thank you very much for staying here, and see you later. Bye-bye.